Hey there, in this video we're gonna create this sort of flower all created in geometry nodes. You can do it like this with the petals, like that. Or we can do it like this, which is optimized for 3D printing, where every single element goes all the way down to the print bed. And we have gaps in between so that we have individual pieces that we can 3D print. Don't forget to like, subscribe and support below. You can get the finished blend file of this over on patreon.com/chrisp. All right, let's do this. So the first thing I want to create is one single leaf or petal or whatever you want to call it. So we go Shift A, mesh, circle. Okay, so we have a mesh of circle, and instead of 32, I want 64 units. I want quite a high density mesh for this because we're going to do some booleans, and more resolution is always more better. Okay, then I'm going to fill this circle with the grid fill, which gives me this. And then in edit mode, looking at it from the top, I'm going to go scale it on the X. And then I'm going to select this one and that one, enable proportional editing, set this to sharp, and scale on the Y to get this sort of shape. Now we can do other things here. For example, we could, let's see, maybe we want our leaf to be a little wider on the bottom, something like this. And maybe we want to bring in the top a little bit, like that. Okay, can bring this out, but I want sharp. GY. Something like that. Okay, you can spend a lot of time designing this, but this is going to be my leaf. Okay, one thing. Now this is just infinitely thin, and I'm gonna give it some thickness. So I'm gonna extrude and give it some thickness. Okay. Now we could go in and do some sculpting and whatever. We can create like the perfect leaf. But for this tutorial, I'm just gonna keep it simple. Now, one other thing though I have to do in edit mode, I'm gonna go select everything and GY, bring it up so that the bottom of my leaf is about where the origin point of my object is. Because if I do that and I go rotate C, I'm rotating around like this, which is what I'm gonna need as soon as I plug in my geometry nodes, which is what I'm gonna do right now. Okay, so let's create a new node tree. This is the leaf input and this is the leaf output. For some reason, I cannot simply click and drag anymore. I always have to click and select first. What is this? Click, drag, click, drag. I just upgraded to the latest 4.3 alpha Blender and now this works again. Cool. So we have one leaf. Now we want to rotate this leaf around and create many of those. So we're gonna need a repeat zone. Repeat zone, plug that in here. We start with one, and inside of the repeat zone, we can set the iterations. And in here, we're actually just gonna go geometry join, plug that in here. And we will join, let me put this way to make this clear what's happening. Okay, so we're gonna join in this leaf, like right here. And inside of the geometry, we take the geometry from the last iteration. We rotate that geometry. Okay, so we go transform geometry. Let's just look at one, and we will rotate this geometry 137.5 degrees on the Z-axis. Okay, and if you know why I'm picking 137.5 degrees, drop a comment down below. It's sort of a magical number. Okay, so we have one leaf, we rotate that around, and in that first single iteration, we then add our original leaf back in. Okay, so if we do this multiple times, we get this very natural looking distribution of leaves. Now, on each iteration, I don't just want to rotate all of the geometry and then add one leaf back in. I want to also scale it, make it a little bit bigger, but only on the X and Y. So let's do like 1.05. Okay, so we get this. Now, how do we get gaps in between here? So if we have this, and on this iteration, this leaf here gets added in, it would be kind of cool to use this geometry and cut out the leaf that we're adding back in to have a gap. So how can we do that? Well, we're gonna have to use a Boolean modifier. So let's go mesh Boolean. And really what we want to do is plug that in here. So inside of the repeat zone, this is always like the big geometry with all of the leaves, and then coming in from here is only that single one that we're adding on each iteration. So we take our big geometry and we cut away, that's what difference is, this new geometry, the one that we're adding in. And we already get some weird stuff here, but we don't get a gap because we're just cutting and then we're adding that leaf, so we don't really have a gap. How can we get a gap? Well, the thing that we're cutting away, so this line here, should actually be bigger, right? So if this is our leaf that we're adding, we would have to make it a little bit bigger and cut that out of this geometry, and then that gives us the gap that we're looking for. So how can we make something bigger? Well, let's look at one leaf. This is the one. If we go Shift A and extrude this mesh just a little bit, 0.1, not individual, then we get this. So let's see, this is our geometry. What are the normals here? Oh, this is a big mess. Normals are on the outside, so go into edit mode and then go mesh, normals, recalculate outside. So now the normals are on the outside, and if we enable this, we should get something extruded a little bit, right? So we can make our mesh a little bit bigger. And this, what is this? Let's go into edit mode. We have a lot of very dense mesh here, which kind of throws it off a little bit. But we could go, we could probably mesh, no, we could go face triangulate. And then we have all triangles, which is probably better anyway. And then what does that look like? We still get this bump. Well, I guess I'm gonna live with that for now. Also, like I said before, we could, for example, take the top here, maybe like this. I'm just selecting a path going up here. And how about we take all of these? GC down just a little bit, like that, just to make it a little bit more interesting and random. Okay, so this is the extruded mesh, and the extruded mesh is what we're gonna cut away from this every time and on every iteration, and then that gives us this gap. And the amount of extrusion that we offset here is really the size of the gap. So we get this. Now, like I said before, the more geometry we have, the better this is going to look. But this is what we have now. And I'm kind of keeping it low geometry here, just so that the viewport stays snappy for the tutorial. Okay, of course we get all these edges here, and that's because of that extrusion thing. I'm gonna ignore this for now. Cool, so this is what we have. And now all we really need to do is crank up the iterations. Let me drag that out to my group input, so I have it out here. Let's set that to I don't know. Let's start with 15. What's happening? 15. And then that gives us this. Is this big enough? Yeah, because if I set this to like something like 35, which is a good value, the outside here is already pretty big. Next, I want to create a curve. I want to curve these leaves up like this. So let's just look at a single leaf for now. And how can I make this curve? I'm going to do that inside of geometry nodes. But thinking that I might want to 3D print this, I want to have the bottom stay on the bottom, and I would just want to curve the top up. So inside of edit mode, I'm going to select the top vertices, create a vertex group, call it top, and assign those to the top. So now let's go back to this. Now every time you want to move vertices individually, you use the set position node in geometry nodes. Set position. So with this, I can set the position of all of the vertices, or I can set a named attribute here. And you can see here we have top, which is exactly our vertex group. So now we're only moving the top vertices. Perfect. So how can we create sort of this, this curve like that? I'm going to Shift A, put in an empty, let's do a sphere, doesn't really matter. And I'm gonna look at it from the top and move this sphere up here to the end of my petal. Okay, now I can drag and drop this empty in here and I can get its location. So what do I have to do? I have to calculate the distance from my vertex, let's say this one, to my empty. So I'm going to need a vector math. Set this to distance. Distance from the location of the empty to the position attribute, basically position field of my vertex. That gives me a value. Now I want to plug this into my C over here. So I'm going to need a combine XYZ node. And I'm going to do something on the C, plug that in here so that I have an offset. Okay. How can I align this? Let's just plug this into the C and see what happens. This is what happens. Of course, because where the distance is big, we're moving a lot. Where the distance is basically 0, we're moving not. So this is backwards. We can fix that with a float curve. Plug that in here and flip that around. So that should give us this. And also we can see that we need to change our distance a little bit. We need a math node. Maybe set this to divide and then crank this up so that we're just getting all of the leaf. So now we have the entire leaf's length mapped to a factor between 0 and 1. And we can use our float curve and do something like this. Yep. Oh, let me delete that. Okay, so this is already pretty much it. Like I said before, we could do something like that maybe. Maybe that looks cool, yeah. Let's do that. Something like that. Now, of course, I'm just moving the top because I'm thinking 3D printing, which means I want these to be down here. What we could also do is bring this out a little so that our leaf goes like this and we have sort of an angle here. How do we do that? Well, we're already combining XYZ down here. All we really need to do is also move the Y based on the distance. So we need another float curve. Let's reset that curve, plug this in here and use that for the Y. Where did that just go? That went into the C. Whoops. So like Y like that. Okay. Yeah. However, this is quite a lot. Bring this point down like that. And then we can play with the value of our float curve. Yeah, so we're just dragging these points out in that direction a little bit. Okay. Maybe a little bit more. If you want to 3D print this, you can't go like this, because then you have the overhangs. We want to print this without overhangs. So, something like that. Cool. Again, we could bring in a curve here, so that we're not really moving these back here. How can we do that? Something like that. What if I bring this up like that? Does that even matter? Yeah, this looks better. So this would be without the float curve. We're moving everything over. And because of our float curve here, we can keep those pretty much. Oh, maybe we could even go over here. Something like that. Okay, so this is one leaf. And all of this is just to create this curve and then bring it out a little. Cool. So now if we want to play with this, of course, we have to plug this leaf into our loop down here. So instead of our input here, we're always gonna work with, well, let's bring this in like that. And instead of using the original leaf, we're gonna use our modified leaf. And if we look at this now, we get this. Okay. We could plug in something in here, another math node to multiply this and bring this up higher, just in general. Okay, so now we get this. And what I really want is sort of, if you think of how plants grow, if they grow in the middle and produce new leaves in the middle, and then the bigger leaves, they go flat. Now everything is at the same height here. I want the ones on the outside to be flat and the ones in the middle to have this curve. Okay, so how do I do that? I'm just gonna drop down on each iteration. Just gonna scale this down a little bit. Yeah, let's do that. So we take again a position node that gives us basically this. And now we can do a vector math and we can multiply everything by 1 except for the C, that should be 0.95. So what does that look like? If I crank this up again, does that give us what we want? What is this? No, we don't need this. Okay. 0.98. Yeah, something like that. Okay, so the ones in the middle are quite tall. Why is this happening? I think that's because we're only changing the top, and with the boolean cutting away stuff. Hold on. What if we don't scale just the top, but all of it? And that means we have to make sure that we're not below 0 here. Okay, so I'm gonna go back to my single object, go into edit mode, select everything, and move this up on the C so that we're basically just above here. Okay, that should work. So let's enable this again. So now the bottom is all on the 0 line here, and we're scaling everything down on the C like this. So we're flattening out the ones out here. So can we go like this? Yeah, okay. So we're really flattening out those bigger leaves, the older ones, because on every iteration I take all of the geometry and just flatten it down a little bit. And then I add a new one, take all of that, flatten it down, add a new one, add a new one. So the ones in the middle are the newest ones and they're sticking up high. And the older ones are down here. Metcap. Okay, so we have this cool looking thing. All right. Now let's think about this real quick and maybe improve this a little bit. We already have the iterations out here, which is cool. Let's do 25. And what I also want to plug out here is actually my offset here, the extrusion offset. And I'm gonna call that gap. So out here we have a gap value. And if we look at this from the top, sort of, I can make a bigger gap, or I can make a smaller gap. 0.15 is a pretty good number, I think. Okay, now we have individual pieces. So if we put this on the 3D printer, we can print every single one individually. However, maybe you want to print the whole thing as one. How do you do that? Well, then you really don't need this whole Boolean thing. So we can sort of mute the mesh Boolean, which gives us just one huge combined mesh, but it's a mess inside. If we look inside, can we look inside? Yeah, so here we are looking inside. It's all of the pieces sort of intersecting, which is not what you want. How can we fix that? We could add a remesh modifier, set to voxel, bring down that voxel size quite a bit to something like that, and also probably add a smooth modifier on top of it. Factor 1, repeat 20 times. What does that give us? Yeah, just to smooth out this stuff a little bit. Cool. So if we look inside now, yeah, okay, it's hard to do, but you can see we have sort of one continuous volume. It goes all the way back there. It's all just one volume because of the remesh. Set to voxel, yeah. So that would be that. If you don't want to 3D print this and you don't want these leaves to go all the way down here, let's disable this real quick. And that one, then all we really have to do is not only set the position, where are we? Not only set the position of the top, but the entire leaf, and then you get this. Yeah, also looking cool. Again, we can change the shape here. Do something like that. Or we can make it pointier at the end, but I like it this way. Okay, so this is a bit of a mess. Let me clean this up. So this is our group input. All of this is to create the shape inside of the leaves. So this really, we're really not even using the original input except for changing it and giving it some shape. And then we use that. Okay, so we don't need this reroute node. This is really our shaped leaf. And then back here, all we do is we take that leaf, we add it to our geometry, and all of the other geometry that we already have from the previous iterations, we always rotate, we scale it up a little bit, we bring down the C, add another leaf. Take all of that, rotate, scale it up a little bit, bring down the C, add another leaf. And this mesh Boolean here, that is to make the gaps. So if we do use this selection here, oh, not exists, this one, okay? And then we have the gap, and the Boolean is for the gap. Now, of course, we have to shift a UV sphere, shade smooth, bring it up a little to make this picture complete. Let me know in the comments down below what you think about our cool little flower project. Like, subscribe and support below. Thanks for watching. See you soon.